Hi guys, this is the Algebra 1 Assessment Solutions video for your Week 5 assessment on systems of equations. We're going to go through all 8 problems, even though you only have to choose 4, and I'll show you both methods of which to solve them to hopefully set you up for success with a reassessment. So let's take a look at the first problem. So 6x minus y equals 4, y equals 4x plus 2. First thing you need to do is substitute this 4x plus 2 into y into the first equation. This creates one equation with one variable. And a key component is making sure that when I substitute using parentheses, which was a common error throughout, because my next step is going to be to distribute this negative sign to both parts in parentheses, which leaves me with negative 2, not positive 2. Can then combine like terms and add 2 to each side. And finally divide by 2 to get an x value of 3. So that's half the battle, and now we need to get a y value. And I'll go back to my original equations. And I see that y is equal to 4 times x, which we now know is 3, plus 2. 4 times 3 is 12, and 12 plus 2 is 14. So my final solution, as an ordered pair, x is 3, y is 14. And so when I go take a look at the graph of this, I have my 2 equations in, 6x minus y equals 4, and y equals 4x plus 2. The red line is the first equation, the blue line is the second equation, and the solution to a graph is where they intersect. So with Devils, I can click on the intersection point, and that will tell me it is 3, 14, which is the same thing we got when we solved. Alright, so let's take a look at the second problem. So this is a visual, and to create the equations based on the visual. So the first scale, the first balance, tells me that on the left side I have 3x. And with the balance, that has to be equal to 9. The second scale, on the left side I have 10. And that's going to be equal to 2x's plus 2y's. So I'm going to start by solving for x over here by dividing by 3. So we have an x value of 3. Now that I know x is 3, I'm going to substitute it in over here, wherever I see an x. And now I'm just going to solve for y. Let's subtract 6 from both sides, and divide by 2. I'll get a y value of 2. So my ordered pair solution will be 3, 2. So now we'll take a look at the graph. I have my 2 equations, 3x equals 9, y equals 2x plus 2y. First equation blue, second equation in green. Here's the intersection point. Let's give it a click. We see our solution is 3, 2. Same thing we got when we solved by substitution. Let's go take a look at our first word problem. So Mr. Sharma has a total of 26 dimes and quarters in his desk drawer, totaling $3.65. How many of each coin does he have? So some of you tried to figure this out by creating a combination of dimes and quarters that totaled $3.65, but you ignore the fact that there has to be 26 total coins. So our equations, I will use x for dimes and y for quarters. And we know the total of dimes and quarters has to be 26. And then the value of the dime is 0.1. 10 cents. And the value of the quarter is 0.25, 25 cents. I know that total value has to be $3.65. So those are my two equations. So I'm going to work with this first equation. It doesn't matter which variable you solve for. So I will subtract, let's go with y from both sides. So x equals 26 minus y. And this is what I'm going to substitute into the second equation. So now I have 0.1. I have 26 minus y in parentheses. Everything else is going to stay the same. I have one equation with one variable. So I'm going to distribute through 2.6 minus 0.1y plus 0.25y equals 365. So now I can subtract 2.6 from both sides. And I can combine these like terms. So negative 1 plus 0.25 gives me 0.15y. And 365 minus 260 leaves me with 1.05. And then when I divide by 0.15, I get 7. So I have 7 quarters because y represents quarters. I have 26 total coins. 26 minus 7 is 19, so I have 19 dimes. Let's go take a look at the graph of these equations and see if we get the same answer. So x plus y, dimes plus quarters, has to be 26 total coins. Value of the dime is 10 cents, quarters 25 cents, for a total of 365. So green line is the first equation, purple line is the second equation. Here's the intersection point. And we do get 19 sevens, so 19 dimes and 7 quarters, just like we got when we solved by substitution. Let's take a look at the second word problem, problem number 4. Alright, so we got a park we're going to. It's $10 for adults and $5 for kids. The total number of tickets sold was 548, and they made $3,750. So we want to know how many of each ticket were sold. So I will use X for adults and Y for kids tickets. And again, I know the total number of tickets sold is 548. I know adult tickets cost $10. Kids tickets cost $5, and we made $3,750. So again, I'm going to change this so I can solve it for one variable. I'll subtract y from both sides again. So I have 548 minus y. This allows me to substitute in for x into the second equation. Again, I'm going to insert this using parentheses. So when I distribute, all my signs are good. And I've created one equation with one variable. So when I distribute, we have 5,480 minus 10y. Everything else stays the same. I'm going to subtract 5,480 from both sides. And combine these like terms in the middle. And 3750 minus 5,480 gives us negative 1730. And then I'll divide both sides by 5. Sorry, negative 5. We get 346, which represents the number of kids' tickets. So I know I have 548 total tickets. So I'm just going to subtract the number of kids' tickets. Find the number of adult tickets, and that's 202. So remember, X was adults, Y was kids. So we're going to take a look at the graph. Here are my two equations. The green line is the first equation, the black line is the second equation. You may have had to adjust your scale to get it on the screen. And here's my intersection point at 202, 346, which was the same solution we got when we solved by substitution. So take a look at number 5. Alright, so back to our equations here. I'm going to work with this bottom equation and add x to both sides. So I end up with 3 plus x on the right. So now I can take this value for y and substitute it back into this first equation. Using parentheses. So I have one equation with one variable, and I'm now going to solve for x. So I'm going to distribute, combine like terms. Negative 3x plus 3x gives me 0. So I'm left with 9 equals 4. That is not true and never will be true. I'm out of variables, and if these two things do not equal each other, that means I have no solution. So let's go check out the graph and see if that's true. Got my two equations in here, and what you'll notice about the graph is they are running parallel to each other, which means they'll never intersect. The lack of intersection point means there will not be a solution, and thus the answer will be no solution. So taking a look at problem number 6. This is probably the simplest one of the solving by substitution, as I already have a y value. So I'm going to substitute that into the first equation. To get my x value. Negative 5 times 8 is negative 40. Oh, should be negative 22, sorry. So when I add 40 to both sides, I get 18. So by adding 40, divided by 6, I get x is 3. I already know my y value, so my solution is 3, negative 5. So I'm going to go check out the graph on Desmos. The red line is my first equation, the blue line is the y equals negative 5 equation. They intersect right here. When I click on that intersection point, I have 3, negative 5. Exactly what I got by substitution. So in order to complete the reassessment form, you needed the verification word. This is the point of the video where you find it. It is macro. So when you see that in the form, you're going to insert or type in the word macro for your verification word so I know you've watched the video. Problem number 7 was this graph. We want on the solution and then explanation. So the solution is right here at the coordinate 1, -2. And the reason that's the solution is that is where the two lines intersect on the graph. So that should be your explanation, that the solution to a system when graphing is the point at which the two lines intersect. Nothing on Desmos to show you, so we'll move on to the last word problem and final problem on the choice board. The choice and failure of the case there is about 5 pieces of fudge, which I will call X, and 3 pieces of gum, which we'll call Y. So 5X plus 3Y, costing $5.70. Sarah bought 2 pieces of fudge, 2X, and 10 pieces of gum, 10Y, and it cost her $3.60. Let's pick one of these equations to solve for either X or Y. We're going to work with the second equation. So the first thing I'm going to do is get X by itself, so subtract 10Y from both sides. And then we need to divide everything by 2. So I have a value for X, and now what I'm going to do is take this value and substitute it in the first equation wherever I see X. So 5 and then parentheses my value for X. And again, plus 3Y equals 570. So now I have one equation with one variable Y. I'm going to distribute 9 minus 25Y. 3Y equals 570. I'm going to subtract 9 from both sides, as well as combine my like terms. So when I combine my like terms, I have negative 22Y, and 570 minus 9. Should give us negative 330. So when I divide by negative 22, that's how I'll get my value for Y, which is gum, which should come out to be 15 cents. And now I can go back and use either of my 2 original equations to figure out the price of fudge. So I'll use that first equation. We had 5X plus 3Y, but now I know Y is 15 cents. And that gives a total of 570. So when I multiply, I get 45. Subtract this 45 cents from both sides. And divide by 5. To find out that the price of fudge is $1.05. So fudge is $1.05. Gum was 15 cents. That should be a solution. Let's go take a look at the graph. So as you can see, I've got my 2 equations here. The blue line represents the first equation. The green line represents the second equation. And they intersect right here. And when I click on the intersection point, I get 105 for X, which was fudge, so $1.05. And 0.15 for Y, which is 15 cents for gum. So hopefully that explains some of the errors you might have had. It helps. Feel free to reach out if you have further questions. You can go fill out that reassessment form now, and we will continue from there if you've chosen to reassess. Hope you all are well. Take care.